Today we're going to be starting a new unit. It's going to be all about scatter plots. So I'm going to start with some of the basics on a scatter plot. A scatter plot is a graph used to show if there's a relationship between two variables, and it lets us know how strong the relationship may be. This relationship is called a correlation. So we're going to be working a lot with this word correlation. So here's an example of a scatter plot. So a scatter plot compares a relationship between two values. And in this problem, it's comparing the distance and the cost of a plane ticket. We're trying to see if there's a relationship between the farther I travel and the cost of the plane ticket. And each of these dots represents a different ticket. So they're showing us 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 tickets. So they collected 9 pieces of data and they graphed them. And we're going to see if there's a relationship between how far you go and the cost of a ticket. So each of these dots represents a different ticket. And I kind of explained 2 of these dots and what they mean. Now, scatter plots show a relationship and they let us see how strong a relationship may or may not be. And the way we measure how strong something is by using what's called a correlation coefficient. So it's just a number that we place value on for how strong these dots, when we graph them, how strong they lie together. So correlation coefficients range from a -1 to a +1. Now in -1, the dots are going to be forming almost an exactly straight line going down. So if we were looking at a scatter plot that had a correlation coefficient of -1, it would look something like this. All the dots would be right in a line and they would be going down because it's negative. If we had a correlation coefficient of +1, all of our dots would be going up in a perfectly straight line, or nearly perfect straight line. And that would be a correlation coefficient of 1. Now, in between is a correlation coefficient of 0. So if we're at 0, our dots are showing no relationship. So we're looking at, there's just nothing kind of relating those dots. They're just scattered randomly. So that means there's no relationship between the two things. So we're going to look at these 6 graphs and we're going to see if we can estimate a correlation coefficient of how strongly the data is aligned. So let's start off with what should be the easiest one, is B. We can see that all these dots are in a straight line and they're going down. So this has a correlation coefficient of -1. Kind of looking at E is very similar to B, but you can see the dots are a little bit more spread out. They're not perfectly in a straight line. They are going down, so it would be negative. And it's not perfectly straight, so it won't be close. It won't be a -1, but it might be something like a -0.8, perhaps. Okay. Which means when we look at C is very similar to E. It's just going in a positive direction, but the dots are grouped very similar. So I'm going to say that this has a correlation coefficient of a +0.8. If we jump over to A, these dots, they're moving upward, so we can see that they're going in an upward direction, so it would be positive. But the dots are a little bit further away from each other than in C. So I would maybe say that this would be a +0.4. Okay, so that's kind of what that would look like. Now for D, the dots are kind of generally going downward, so it's going to have a negative correlation. And I would say probably a -0.4 for this one as well. And then lastly, we have F. this is an example where those dots are scattered kind of randomly. So this would have a correlation coefficient of 0. All right, last week you supplied me with some information. Everyone recorded when a paper bridge broke and how thick it was. So this is the data that I got from everyone that submitted it. And we're going to look at writing this relationship in words and estimating a correlation coefficient. So this is comparing thickness and breaking amount. We always start with the x value first, the independent value. So we would say as the thickness increases, we want to then say what happens to the breaking amount. So we can see that these points, and it almost looks like a line because there's so many points in there, but each of them is like kind of a different x. So as my thickness increases, so did the breaking weight. So in words it'd say as the thickness increases, the breaking weight increases, or the breaking amount increases. And then to estimate a correlation coefficient, I might say that this has a correlation coefficient of a positive 0.7, maybe a 0.75. All right, and then let's look at this one. We're comparing distance and the cost of a plane ticket. So we would say as the distance increases, the cost, and we're going to see what happens. So as I increase my distance, I can see that the cost also is going up. The cost increases. And for a correlation coefficient, I might say that this has a correlation coefficient of a positive 0.8. And the last one, we're comparing temperature and the date in April that trees bloom. So as the temperature increases, so as the temperature is increasing, so as I'm going from left to right, I can see that it's going down. So as the temperature increases, the date in April decreases. So the warmer it is, the sooner the trees will bloom. And I would say that the correlation coefficient of this would maybe be a negative 0.8 or 0.9. They're pretty close to a straight line.